Okay, so we're going to talk about how to solve this one-step equation in three different ways. We're going to solve it algebraically, we're going to solve it using a scale or a balance, and then we're going to solve it using a visual representation. So the usual way of solving, or the algebraic way of solving a single step equation, we say that we want to isolate the variable. Therefore, we want to move anything else that's on the same side as the variable. The equal sign separates the left side from the right side of my equation. And to move things from one side to the other, we use inverse operations. So right here we have addition, so I'm going to have to use subtraction. And properties of equality say that whatever I take away from one side, I must take it away from the other in order to keep my equation balanced. We know that 3 minus 3 is 0, so that's 0 right there, leaving me with just m is equal to, well, 8 minus 3 would be 5. So that tells us that m is equal to 5, right? So 5 plus 3 is equal to 8. We can see that that's true. Another way to think of this problem is we can think of an equation as a balance. In order for us to create this equation, I'm going to need an m. Since I'm using algebra tiles, they're labeled as x's. So I'm going to use an x to represent the m, and that's going to be on the left side. I'm going to need 3 of the ones. So 1, 2, 3. I'm going to take those 3, move them on the left side. On the right side, I'm going to need 8. So here's 3. There's another 3, and then I need 2 more. And previously I had done this and I had told it to balance it. But you can always click and say, hey, balance this equation. So here I have x plus 3, or m plus 3, is equal to 8. It's balanced. And what we say is, hey, I want to leave this x by itself, but I need to keep this balance. Meaning if I take something out of here, I also need to take it out of the right side in order for it to stay balanced. Let me put them back in there. Now, if I put something in here, if I add more pieces on the right side, then I need to add the same amount of pieces on the left side in order for my equation to remain balanced. My goal is to leave the x by itself. So what I could do is I could move these 3 pieces out of there, right? 1, 2, 3 pieces out of there. In order for this to be balanced, I need to take the same amount on the other side, right? So 1, 2, 3. And when I take 3, I see that it's balanced again, just like we did here, right? We subtracted 3 on this side, subtracted 3 on that side. Well, what does that mean for us now? It means that x, or the one that's representing or taking the place of the m, is equal to 5. 1, 2, 3, 4, 5 pieces. Right? If I want to verify, just like I did here when I put in 5 plus 3 equals 8, I can put these back in there. Let me take this one out. Put these back in there and replace the x with 5 pieces, right? So I'm going to take 5 pieces and dump them in there, and it should be balanced, right? So this piece right here, this section right here was taking the place of the x. So we can see that it's balanced. The other way in which we could solve this equation, let me make this larger. Here we go. Okay, we can think about this as, hey, m represents this box, this container. I have this container plus 3 pieces, 3 positive pieces, and all together I have a total of 8 pieces. Well, we could think about it as, well, these 3 pieces could be representing these 3 pieces right here, right? They're the same. And so whatever else is over here would be equivalent to what's inside this box. Meaning that it looks like I would need 5 pieces, and I can verify it, right? 1, 2, 3, 4, and 5. And 5 pieces plus 3 pieces would equal to 8. We could think about it as in the same way that we did using the algebra tiles and the balance. We could say, well, originally I had this, a container with some pieces in there, plus the 3 pieces that were out here, equal to a total of 8 pieces. Well, if I take these 3 pieces out, just like we did on our algebraic equation, and I take these 3 pieces out, what's left over is what's inside that box, right? So there's 5 pieces left over inside that box. So 3 different ways of solving a one-step equation.